Today we're talking about Level Up 8.4, not mutually exclusive events. So remember, mutually exclusive events are events that cannot occur at the same time. We covered that in the last lesson. But now the book's going to go back to George playing his game, and George realizes that to land on a safe spot, he can't get 5. When he rolls that dice, he cannot roll 5. To land on a safe spot, he has determined that he needs to roll a number less than 4 or an even number. Now, this is very silly to me because it's very much like the other example, but they've reworded it and, in my opinion, making the thinking of it more complicated. Because you can just solve this problem according to the way we handled the last lesson. So for sake of review, I'm going to walk you through that. The probability of the safe event is if he rolls the dice and it gets 4, 3, 2, or 1, so less than 5, or greater than 5. If he gets a 6, he'll be safe there too. So these are mutually exclusive events. Thinking of it in this way, these are mutually exclusive events. Now in a second, we'll get to the way the book talks about it, in which case it's not mutually exclusive. But thinking of it this way, it is. So if P is less than 5, or I'm sorry, if the dice, you roll the dice, it's less than 5, you could get a 1, 2, 3, or 4. Well, your chances of getting 1 is 1 out of 6. And your chances of getting 2 is 1 out of 6. Your chances of getting 3 is 1 out of 6. And your chances of getting 4 is 1 out of 6. But he'd also be safe if he rolled a 6. So that's the greater than 5. And there's only one greater than 5 on a 6-sided dice. So if he rolls a 6, that's another 1 out of 6 chance. You add all those up, and you get 5/6. Now, the book is having George think in a more complicated way so that they can introduce the concept of not mutually exclusive. George is thinking, well, I could roll a number less than, you gotta give me a second because he thinks of it so weird. He says he needs to roll a number less than 4. He can roll less than 4, or he could roll an even number, Now, if he rolls an even number, if he rolls, let's look at rolling less than 4 first. He could get 1. He could roll it and get 2. He could roll it and get 3. And now we've covered all the numbers less than 4. Or he could roll an even number. Now, on a 6-sided dice, the only even numbers are 2, 4, and 6. But notice now that 2 is listed twice. So if you were to just go 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6, it would appear like that equals 6 over 6 equals 1, which equals 100%. He is guaranteed to land on a safe spot, except that he's not. If he gets a 5, he is not safe. So what you have to do is come up with the probability of event A, which was 3/6. Then you also have to add in the probability of event B, which is another 3/6. And then you have to subtract the probability that's in both. So 2 shows up in both. So you need to remove one of those. So minus 1/6. And you'd get back to what we already knew it would be by thinking of it the easier way of 5/6. However, there will be times in life where you would need to know about the mutually exclusive if you work with something to do with probabilities. So knowing how to handle those events that are not mutually exclusive is beneficial to you. So just know this formula right here. The probability of events A or B equals the probability of event A plus the probability of event B minus the probability of both. All right, so we're going to look at an example that's on page 387. Using the spinner, to the right of the screen, this green and blue spinner, express each of the following probabilities as a fraction, a decimal to the nearest hundredth, and a whole percent. So the first question is, what is the probability of spinning a green area or an area with an even number? So once again, we have two different probabilities. We could get the probability of a green area or the probability of getting the even numbers. However, the green areas are 6, 1, and 2, and the even numbers are 2, 4, 6. Well, here we have a 2 in both lists and we have a 6 in both lists. So what you would do is out of the probability of getting a green is going to be 3 out of the total possible outcomes of 6. And the probability of getting an even is 3 out of the total possibilities, which is 6. So you're going to add those together, but then you need to subtract the ones that are duplicated. So there are 2 duplicates, the 2 and the 6. So you need to remove one set of those probabilities that you already added in. So you get 3/6 plus 3/6, which is 6/6, minus 2/6, which equals 4/6. And that is about, it reduces down to 2/3, and that's about 0.67, or what on earth is that? It's a backwards R. Or, I swear I don't know what goes on between my brain and my hand. 67%. Okay. All right. So what is the probability of spinning a blue area or an area with a number less than 5? So the probability of getting blue is going to be 3 options. There are 3 possibilities out of 6. And the probability of getting less than 5 would be Remember, when it's less than, that does not include that endpoint, that 5. It's not less than or equal to, it's less than. So we need 1, 2, 3, and 4. So we do 3, 6 plus. There are 4 possibilities that we just outlined here out of 6. Now, the blue numbers are 5, 4, and 3. So what is duplicated? We have a 3 duplicated, and that's it. No, 4 duplicated. 3 duplicated and 4 duplicated. So that means we need to remove 2 of the 6 because they've been counted in there twice. That gets us to 5, 6, or about 0.83 or 83%. All right, that's it. Good luck with your homework.